Alrighty, so we've got negative 7.2x plus 1.8 is greater than negative 19.8. So we have to solve for x. We have to get the x on its own. This is an inequality because it has an inequality sign and not an equal sign. It's not an equation, it's an inequality. So what we want to have at the end is something like x is greater than 3 or x is less than negative 1 or something like that, right? So we want to isolate the x just like if we were solving an equation. So we have to undo the operations that are applied to x to get it on its own. So it's being multiplied by negative 7.2 and then 1.8 has been added. So if I subtract 1.8 from both sides, okay, let's do that first. That will at least get... So subtracting 1.8 from both sides means that this makes 0. So we just have negative 7.2x is greater than, and if we combine these, remember it's kind of like if you had negative 10 and you subtracted 2, what would the answer be? What's negative 10 minus 2? Negative 12. So it's like I'm in debt by $10 and then I spend $10. Now I'm in debt by 12, right? So that should happen in this case. We should end up with a more, a larger negative number, so to speak, right? So we've got to go 19.8 and 1.8 and add them, right? And then the answer will then be a negative number, right? Because it's negative, I'm in debt by $19.80 and I spend $1.80, so I'm going to be in debt even more, right? So 8 and 8 is 16, put 6 down, carry 1. 16, put 6 down, carry 1. And this makes 11, carry 1, and that makes 2. And then when you're adding decimals, this decimal point goes here, right? So now the answer is negative 21.6 over here. So if I'm in debt by $19.80 and I spend $1.80, I'm now in debt by $21.60, right? Okay, so x is being multiplied by negative 7.2. To get it on its own, we need to divide by negative 7.2, correct? Now, on the left here, negative over negative is positive. 7.2 over 7.2 is 1, so I just have positive 1x, or just x, right? Now, I'm dividing both sides by a negative, so what should we do with the inequality sign? Stay the same or change direction? It would change direction, right? The reason for that, everybody, is, let's just give you a simple example. Here's negative 10, here's the number 30, okay? What happens when I divide both sides by positive 2? By the way, negative 10 is less than 30, right? Negative 10 is less than 30. What happens when I divide both sides by negative 2 compared to dividing both sides by positive 2? What do I get in each case? So if I divide both sides by positive 2, I get what? Negative 5 here, and what do I get here? 15. So which is more, which is less? Okay, so the inequality stays the same direction when we divide by a positive, right? But when we divide by a negative, what's negative 10 over negative 2? Positive 5. And what's 30 over negative 2? Negative 15. Good. Now which is more, which is less? Yeah, 5 is more than 15. 5 is greater than 15. So see, when we divide by a negative, that's when the inequality changes direction. So we need to remember that, right? Okay, so that was a quick reminder. So the inequality changes direction. Now I've got a negative over negative. Before we do the complicated division of the decimal, what is negative over negative? It's what? Positive, right? So we know the sign should be positive. So we can just do, 7.2 into 21.6. Agreed? And when I divide negatives, I must move the decimal point one spot to the right. So it's 72 into 216, right? Now, what do you think that would be? Take a guess. Good point. If you block off that 2, you're just looking at a 7. And if you block off this 6, you're looking at 21. So 7 into 21, 3 times, right? So that makes it a little easier like that. Right? So 3 is a good guess. 3 times, and then we multiply. 3 times 2, 6. 3 times 7, 21. And now we subtract remainder 0. So this divided by this does in fact make 3. And again, it's negative over negative, so the sign is positive. So you have x is less than 3, right? We're going to stick that on a number line. Just draw from number lines go from negative to positive infinity, and they have 0 in the middle. So let's do that much. So where's 3? It's over here somewhere, right? There's 3, right? Now, if x represents all numbers less than 3. So give me some numbers that are less than 3. 2 is less than 3, so is 1, so is 0, good. All these, right? Any of the negatives, right? How about 4? Is that less than 3 or 5 or 6 or 7? No, so not these guys. So all these guys and everything in between, it's the decimals as well. So we kind of fill in the line because it's not just the whole numbers or the integers, it's all the decimals. Every single number on the number line, right? Now, is 3 included as part of this set? No. So do we use parentheses or square brackets? Parentheses, because that's when something is not included. So we go parenthesis like that, not included, right? And if I was to do an interval, it would look like this: min, comma, max. What would the minimum number be in this interval? Negative infinity, yeah, and the max would be 3, or 2. Yeah, theoretically 2.9999, but I mean that goes on and on forever, so it's hard to represent that, isn't it? You know, and in fact, if 2.999 did go on forever, that would actually be equal to 3. But that's a philosophical debate. Well, that's a fact, but I'm not going to go into that. So it's 3, but not including 3, so we put parentheses there. And we can never reach negative infinity, so we got to put parentheses around it like that, right? And just for fun, if it was in fact x less than or equal to 3, it would look like this. Square bracket on the 3 all the way to negative infinity. And the interval would look like this: negative infinity, comma, 3 with a square bracket. Got that? So because it's just less than, we use parenthesis, but when it's less than or equal to, we use the square bracket. Good?